Can you see my screen? Can see my screen?
Yes, yes.
Yes, yes.
Good afternoon, everyone. Let us start our lecture today. Before that, I want to show you yeah. Can see the screen? Can see?
Can.
Can So this the upper one is the chips It's the die So substrate is the bottom one. This is the reverse as I say So this one is the flux must take action first So as you see this is the one attached on the die one, and this one is at the substrate So they must be aligned okay. Then after that they will go for refill Slowly the temperature will ramp up you see it will slowly melt so it will not melted on the substrate the solder resist only it will sit on the bonding pads so it will melted and form the joint so at the end of the section right uh, so at the end of the section it will just like forming a good bonding this is uh, what I'm talking about last week right so now I'll let you see another one you can see right so this is underfill dispenser okay so some of them will just dispense at the center but normally they will dispense one line so that it will move equally sometimes they will span L shape also L shape so it will slowly move so this one I think is only one line so it will dispense like this each of the units that need to be underfilled so this is the underfilling process it will dispense like this okay so the black color one is the underfill so it's liquid so it will flow inside okay it just flow inside so this is what we call dispenser it will dispense like this so have another one this one this is from Asyntec Asyntec is another supplier underfill machine okay it's a blend like ours like Instrong Hake Asyntec is the blend okay so this one they just scan the unit see where's the position then after that they will dispense see dispense at one line like this one quite fast okay then not enough if the volume is not enough it will dispense second time so that to make sure it will travel until the end yeah so very simple process right okay so like this is scanning you see there's a red light right see the machine will scan you see red light the one is to detect the unit okay where's the unit position so that the robot can dispense accurately So we continue our lecture. Have you signed in your attendance? Have you signed in? Please sign in your attendance now. Okay. So the link I will post it one more time. I will post it. I'm posting it inside the chat box. Okay. So please sign in now. Okay. Please sign in now. Okay. Can see the screen, right? Today only 31.
Can.
It's not coming. Ay, every week also like this. Nasri not here. Nasri not here. Mm, should we continue? Okay. So the day we start until here. Okay. So underfill is actually is a composite It's a thermoset composite. Just like you're studying polymer composite, right? So one composite must have one complete system. No matter is thermoplastic, thermoset or rubber, right? So it must have a filler matrix. Okay. So normally silica we are using silica we are using. The filler we are using silica. Okay. We're using silica as a underfill in epoxy. The function of the filler is to control the viscosity, modulus, and of course the CTE. So ceramic, the CTE is much lower than polymer. So it can lower down your um, original own. If pure polymer is can up to 80 to 100, 150. Very high. So if you add in the silica, right, actually can lower down up to 60. Substrate only 20. Substrate only 20 because has a core layer. The core layer, last time they used the Knauf, not Knauf, FL4, the one, what we call grass fiber, woven grass fiber. So then the hardener must is a must. This one to provide cross-linking and also the impact toughness. To control your final properties. Okay, so if you need to cure it fast, then you need to speed up your cross-linking rate Okay, increase your cross-linking rate So at the other additive you can add in like dye pigment surfactant adhesion promoter. Okay, so this make a complete formulation. Very easy only. The complete formulation is just like a composite system. Okay, a composite system. Okay, so when we put in the what is this? Uh, when we put in the filler, right? When we put in the filler, right? Normally, you need to see there's an optimum level. Okay, there's an optimum level. So what happen if you put your filler content too high, and what will happen when you put your filler rolling is too low. So this is a graph showing you that whereby we have the x is filler rolling. Okay, x is filler rolling. Okay, this one filler is what? If underfill, normally is silica lah. Okay, so you see the y we have two axes. One is CTE, so with the unit. Okay, your program must have the reading and the unit. Modulus, okay, this one gigapascal, very high. Okay, so this one this line is CTE lah, and this line is molars. So what you can see right now, what you can see, what happened if your filler increase? What happened to your CTE? What happened to your CTE? Decrease, CTE decrease. Why? Because ceramic, silica and ceramic is lower. It has lower CTE than your polymer, so increase your filler normally decrease your CTE lah. So original at 80, so it slowly increase. If you add up to 80 weight%, and then it's around 20 only. Okay, so what will happen to your molars? Increasing, right? Okay, because ceramic is very hard. So when you add in the filler, the molars will be increasing lah. Okay, what will happen if you add filler loading too low? So if too low means molars is very low, then the CTE is very high. Okay, so if CTE is very high, okay, so you cannot like play the role for the matching, right? So you will have solder bump fatigue. Okay, you will have solder bump fatigue. And also the molars is very low. Okay, so it cannot protect your bumps. So you will have solder bump fatigue. Okay, so let's say if you put up to 80, of course CTE is very, very low, right? But then it will be too hard. It will be too hard. If too hard, also is going to cause problem because it's too hard. You cannot distribute the stress. Okay, you cannot distribute the stress. What's the function of your underfill? What's the function to underfill? All the stress will go to underfill, right? So underfill, it will convert the stress into deformation. So it will bend. It will have bending. Like I say on last Tuesday, it will bend a little bit. What we call like warpage, right? Still remember the word warpage? Okay, warpage. Still remember this word? I explained to you warpage. It will cause warpage. So if you're too hard, then the thing cannot be bended. So it will cause all the stress will go where? Go to the die. So you will have die cracking. You will have die cracking. And also the lamination between your die and the underfill or underfill with the substrate. Okay, so in conclusion, you must have an optimum, okay, at the center, optimum, so that it will play the function well. Okay, so you see if too high, the modulus is very high, CTE is very low. Of course, CTE very low, less thermal mismatch. You can overcome the thermal stress. But then if too stiff, the stress is not able to be converted into deformation. So the stress will go where? Go to your dial. Okay? So if too low, you still will have CTE mismatch problem, right? Then you will generate thermal stress. So all the stresses will cause you total bump fatigue. Okay? So since I already explained up to underfill, right? Okay, we stop for a while. I want to explain to you assignment. So whoever you have time on this Raya, you can do your assignment. Let me share. I explain to you the assignment. Later I will post inside the e-learning so that you will have more time to do for your assignment. Okay? Okay, can see the screen? Can see the screen?
Can.
Okay, can see, right? Okay, so assignment one. As I say, it should have assignment one and two, and presentation one and presentation two. Since you have your FYP two, So I want you all to have more time on your in your for your FYP lah. So only one assignment from me and only one presentation from Dr. Sina. Okay? If Dr. Sina forgot to give you all the title earlier, you please remind her so that you will have more time to prepare for it. Okay? So submission date is in May, but I let you know, I explain to you right now, so that you will have more time. You don't tell me you don't have time to do this. Okay? So now it's only April. One month to go. Okay? You have one more than 1 month to do this one. So this one assignment, as I say, how many percent? How many percent? How many percent?
5%,
No, more than that. Only one
10%.
assignment. 10. 10%, you know? 10 can determine whether you can score A or not. Okay? Okay. So one individual report. Individual report tahu kan? Tulis sendiri. Jangan main copy Copy juga nak mesti ada teknik. Jangan exactly the same. You don't let me know you copy from your friend. Then you and your friend will have same mark. Whereby only if 10% only you have 5%. The maximum. The maximum, Okay, both will have same mark. Maximum only 5%. Means 100% you only can get 50%. Ah, don't let me see exactly the same report from you and your friend. Okay. So where to submit? Submit in e-learning. Later on, I will post it. Okay. So if you realize, I already posted 3 lecture notes. So in this Raya, if you have time, you can start to study. Lecture notes number 1, number 2, and number 3. Test 1 will cover these 3 lecture notes. Okay? Only these 3 lecture notes. Faham? Clear? Clear or not?
Clear, clear.
Okay. Submission date 19 May 2024. Okay? 19 May 2024. So 19 May is going, it's a Friday. It's a Friday. Okay. We go to the questions. Okay. So what is this? This is something I show you before, right? Okay. The true wear one. Still remember the chips we make a wear? Okay. Okay. This is substrate. Okay. This is substrate. Green color, light green is the substrate. So this is a solder ball. Okay. So the bottom one, this is what? PWB lah. I didn't label here. So you know lah. This is thermal test board. Okay. Or PWB also can lah. Okay. So this is substrate. Okay. So this is silicon chips. The gray color one. Okay. The gray color one. This one. This one. Silicon chips. This one silicon chips. Number 1. This one, the dark blue one, also silicon chips. So you have 2. This is the red one, also the die. Also the die. This is number 3. Okay? This is number 3. Okay. So you have 3 die. Actually, you have 3 die. Okay? Up to here, can understand? And this is your solder bump. The yellow one is your solder bump. And the gray one is your bonding pads. Okay. So this one is your solder bump. Okay, this one is your solder bar. Okay, so you have silicon die 1, 2, 3. Okay, so the problem is like this. This company Y is producing a high performance electronic package for processor. Okay, processor die and a memory die. Okay, processor die attached together with your memory die. Eh? Using true silicon via. So it's not using wire bond lah. Okay, because you have these micro bumps. So no wire lah. Eh? If no wire means must use underfill. Okay. So you see inside this figure, you have how many underfill? How many place you have underfill? Okay. So you have A1, A2, and A3. Where is it? Underfill A1 here. Okay. Yeah. Maybe I put this one. Maybe I put this one. The tree. Okay. You listen carefully. It look complicated. It's actually not complicated. Okay. So I explain to you. So you have underfill A1 here in between your die number 1 and your substrate. Okay. So then you have underfill A2. Where's A2? Your die number 2 with this die number 1. Okay. This is the location A2. So A3, where is it? In between your die number 3 and your die number 1. This is the one. This is the one. Okay. And all these underfill A1, A2, and A3 actually are the same grade. Same grade means what? Same material from the same supplier. Same material, same supplier, same company. Okay? Dari ibu bapa yang sama. Okay? A1, A2, A3 ni dari parents yang sama. Okay? Ah, same grade also. However, that's a problem. However, underfill voids only observed at A2 and A3. Huh. A1, this one no voids. But then this one A2 has void. And A3 also has voids. Okay? Only observed as underfill A2 and A3, but not happen at A1. But then they are the same materials. So you must think. Okay? Then you must think. Why is it like this? Why is it like this? Many possibility. Okay, so you are being asked to make a report to analyze the possible cause. Why? Why is it happen like this? What is the cause? And suggest the potential solution. And suggest the potential solution for each of the possible cause that you have discussed. Let's say the cause. Okay, the cause, you have cause number 1, cause number 2, cause number 3. Okay, you have this cause. Okay, so your solution must based on this. Okay, so this is the cause. So later on, you give the answer for solution. So right now, the solution number 1 must be able to solve your cause number 1. Okay, solution number 2 must be able to solve your cause number 2. And if you give solution number 3, then must be able to solve. So it's linked. 1, 2, 3, 1 to 1 solution. 2 to 2 cause and solution. 3 to 3 cause and solution. I want like this. Okay, I want like this. Understand or not? Can? Can follow? Can follow? Can follow or not?
Can.
Can Can follow Okay. Okay, let us see the rubric So you must have this one and this one Okay, you see the rubric. So 4, 5, 6, 7, 8, 9, 10. Total 100% Okay. Must have intro lah. Must have introduction. Introduction 10 marks. Okay. Possible cause 40, solution 40. You see? This one how many cause? You must have how many solution Okay. Okay, depending on how you write lah. You want to separate the cause 1, 2, 3, 4. Solution 1, 2, 3, 4 but matching 1 to 1 or 2 to 3. Or you want to make a table cause 1, 2, 3, 4. Then your solution 1, 2, 3, 4 also can. Okay, depending how you write. As long as you have matching you have cause, then you must have solution. The solution must be the one you mention. Don't give the solution that you never mention here. Then no marks Okay, then will be no marks Okay, then after that must have conclusion Okay, conclusion and also references. Okay, so clear or not? What you need to do? Clear or not? Anything to ask me? You can ask now. Anything to ask me? You can ask now. Any questions? Any question? Ah, yes?
Causes how many?
Huh?
How many causes?
You see
Possible causes.
40 40. So you estimate how many courses. I cannot say you must have how many courses Some of the student only give 2 courses, but very good explanation. The one I also will give mark. Some of the student give 4, but then no explanation. The one the marks cannot have 40 lah. So once again, I don't want to say like how many, depending on how many point you have. You see how many point you have. Once again, like final exam how many point you have. Okay? One course, if explain in detail, you have many point. Okay? Of course, cannot be only one course at least 2 right? 40 Of course, cannot have one only Okay? So, um, any more questions? Any more questions? At least 2 No? If you give 4, also can. But with explanation not only 4, no explanation. They only can 4 also cannot get 40 You understand Okay? So any questions? I give you some clues I give you some clues You see carefully You see carefully. You go and find So substrate, the surface is soda resist. Okay, it's soda resist This surface on the substrate is different from on the die. This one is between die, die and die. This one is between die and substrate. So that's the differences. That's the differences. Okay, you go find out. You go find out. Yeah, this is very common right now. It's not something new. Okay, so you go find out. Okay, what will be the cost? Can. Huh? So this is polymer, Substrate is polymer, Another clue lah. See, already give two clues, Not supposed to give, Okay, substrate is polymer, yeah. But this surface, contact in between underfield in this one is not polymer. This second clue. Whether you can catch or not. This is 2 point. This is 2 point. One is the surface materials is different. Another one is substrate, one is dye. Okay? Okay. Maybe you will have more one. Okay, if you go and read through, we'll have more. Okay, so you go find out. Okay? You go find out, Okay, any more questions before I close it? So I will post it in e-learning. Okay, so you have, remember 19 now? 1 month to go. But don't forget, don't forget to do. Okay? Janganlah bagi sampai 1 bulan, lepas tu tak boleh hantar lagi. Betul tak? Cannot be like I already given you more than 1 month. On 19 also you cannot submit. Then I got nothing to say. The one 10%, 10% can determine whether you pass or fail. And also can determine you whether you can get A minus or B plus. Okay? 10%. So I only will give you assignment. Dr. Sina will give you presentation. Clear? Clear? Before we move on to lecture, clear? Are you clear? Ada respond tak? Siapa clear? Jeff
Clear,
clear.
clear.
Sean clear. Muri clear. Yang lain? Satwan also clear. We continue. Kitana also clear. Okay, good. Good. At least you give a response. Okay, we continue with our lecture. Let me share our lecture. Ada masa, Raya ada masa. Bacalah sikit. Week 6 we have test 1, Week 6 we have test 1. Okay? At least you have opened up and see the lecture notes. So I have posted lecture notes number 1, number 2, and number 3. Okay? Test 1, 2 questions. 2 questions, 20 marks. Okay? Clear, Okay, we continue our lecture. Hey. Okay, so now, what is this picture? I want to ask you. This picture from what testing? From what testing, this picture? Sudah belajar polymer blend kan? This picture from what testing? Huh? This picture from Iyasha. Iyasha? 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 Iyasha ada? Iyasha? Ayya. Ada ke tak ada? Oh, sudah tak ada. Betul lah, tak respon. Kita Raya. Maisara. Maisara? Ya, betul. SEM. Okay? SEM, Betul. Okay, so what's the difference between these two pictures? What is this round one? What is this round one? This one silica lah. This one silica is called fused silica. Is round one. You use for underfill must be round one. Okay? So you see, the gray color one is the epoxy lah. It's a thermoset lah. This black is actually what? Your dye lah. Okay? So the gray, light gray one, light gray pula. Dark gray one is your resin lah, your matrix. Faham ah? Okay, this one eh? This one all gray, you see? This one got dark lah. Got darker color. Means what? You see all the filler? Settle down, right? Means this is resin lah. More resin. More resin. Means not homogeneous lah. What's the effect? This one very homogeneous. So this one will not have warpage because homogeneous, well controlled by the filler. But this one, you see, this one less filler. Less filler means what? Your CTE is high here lah. Then your CTE is low here. Then of course you will have in between one underfill material already you will have what? CTE mismatch. Then of course you will have your warpage. Okay? So homogeneous dispersion is very important. This is what we call filler settling effect. Okay? Clear or not? Clear or not? Huh? Oh yeah. Why no respond?
Clear,
Clear,
clear.
clear.
Okay. Now we go to see resin itself. Resins we have many types, right? You as a polymer student, you know resin we have epoxy itself have many types. Okay, also have many types. So have different functional group, right? Okay, so you see different functional group will give you different properties. Like this one K1C. Okay, so if you are using anhydride, you have higher K1C. What is K1C? What is K1C? Megapascal root square of M. What is this? What is this? What is this? Composite sudah belajar ke? Polymer composite got study this K1C or not? Ada ke tak ada?
I think don't have.
Don't have. So K1C is what we call fracture toughness. Fracture toughness. To be in your polymer composite syllabus. Okay. Okay. So this one, when you have anhydride functional group will have higher fracture toughness. Okay. Ether lower lah. So other than different functional group, you study about molecular weight, right? I want to ask you. Okay. I want to ask you, why we need to know about molecular weight? Anyone? Why we need to know about molecular weight? From introduction to polymer first year subject, you already learn, right? How to calculate average molecular weight. Is it? Got or not? Still remember or not? Still remember or not? Huh? Processivity. Okay. So processivity is important for processivity. Yes, yes. Okay. So in terms of processivity, low molecular weight easier to process or high molecular weight easier to process? Huh? Low easy to process or high easy to process? Low easy to process, is it? Huh? Jeff, you're right. Low, easy to process. Okay, low, easy to process. Okay, so this is current molecular weight. If they use the higher molecular weight, maybe processing will be difficult, but then it will give higher fracture toughness. Okay, so it's depending on, once again, it doesn't mean that high molecular weight is bad lah. Sometimes it will give you better properties. Then in terms of processability, you must find a way to solve it. If you need to achieve, okay, let's say this line is the target. Let's say this line is the target. Okay, so this one, the current one, cannot achieve. So you must use higher molecular weight in order to achieve. So, so no matter how, you must find a way. This is engineer. You must think a way to solve your possibility, processability. Okay? So, or you want to change different functional group. Okay? Either or. So, you are a polymer student, so you should know what to do. Change molecular weight, or you want to change different functional group. How to know? How to know? You must ask data from your supplier normally. Okay? Normally, you must ask data for your supplier. Sorry, let's just continue. So you must ask the data from your supplier lah. So if your company doesn't have R&D department, so normally you may ask help from your supplier to give some data for you in order for you to make decision. Then after that, you need to try run lah. You cannot like one time you go for high volume production manufacturing. So later if cannot use, then that will be a waste. So some of the company they will have R&D. So you need to do the research first before you go for uh, uh, huge high volume manufacturing. If you don't have the R&D, so mainly you need to ask the data from your supplier already. Okay, okay. So another one will be your catalyst. Catalyst, we have latent catalyst. Catalyst not necessary fasten the reaction. This one is to relay the reaction so that to relay the cross-linking reaction so that you have more time for your processing before the thing cure. So we have something like latent catalyst. Okay, so normally catalyst we use is to fasten the reaction, right? So that it won't waste time lah. So but this catalyst it will influence your you need to be careful with the gel time lah, especially for thermoset. Okay, cannot gel too fast. Gel too fast, you don't have enough of time to do your processing. This one also later I will explain in detail. Okay, so you must have sufficient flow time. Okay, for the flow, material flow from one distance to another distance to have full fillet coverage, or else flow halfway already gel. Then dangerous defects. Okay, then you have reject rate. So you must control your reaction so that it doesn't happen too fast or too slow. Too fast, incomplete. Too slow, you're wasting your time. Okay, you're wasting your time. So your production will be low lah. Okay, and also to avoid internal build up stress. Eh? So this course is actually the application of what you have learned, how you apply in the processing, okay, in your product processing. For this electronic application, what you have learned. So this course put in 4th year. Okay, another thing, hardener, you know, right? Function is to give cross-linking, to give 3D network system to enhance your toughness and mechanical properties or thermal to your underfill materials. Additive, especially adhesion promoter. What's adhesion promoter? What is this? Normally, you know. Uh, Normally, you know this. Know this or not? You know this or not? You know this or not? Learn before or not? Yes or no? Yes or no also cannot.
Yes, yes.
Yes or no also cannot answer. Oh, Lama. You know, last time one of my friend, when I'm studying from Indonesia, is a Malay lady. Puasa month, she went to have sport with us around 5 something. Almost every day, puasa month, wow, very active. Still can play sport. Then after that, we send her to buka puasa. Okay, so to provide good adhesion to both dye and solder mask. eh, So to have good adhesion, so underfill when you do what's the function? Must have adhesion with your dye and also adhesion with your substrate, right? So you must have good interaction. Okay, so you need to put saline or siloxane, any adhesion promoter. Okay, so that you will have good adhesion. Then you can to differentiate the color. You can put dye or pigment. For example, you put carbon black. Just now the video I showed you, you see the underfill is black color one. Why black color? Because want to see easily to see. Easily to see whether it's already filled up or not. Okay? For example, this one. If all same color, how to see? Must have different color lah. That's why they put the pigment. Eh? Another one is flow modifier. We have something like flow modifier. This one is to lower your viscosity. If you have flow modifier, normally the viscosity will be lower and constant. Okay, if without, right, with apply stress, the polymer will decrease. Okay, if you have flow modifier, is like almost constant. Okay, if without, because urology, right, polymer is not non-Newtonian behavior. You apply stress, viscosity will decrease. Okay, so in conclusion, key parameter to consider before selecting an underfill materials. First, because when doing the processing, the underfill is in liquid thermoset, right? So flow behavior is very important. Is it able to flow well? Viscosity control. How in order to control the flow is the key will be to control the rheology and control the viscosity. You know, right? High viscosity difficult to flow. Low viscosity easily to flow. But if too easy to flow, it will overflow. When it's overflow, also will cause problems. So, what is the optimum viscosity? You are the one to decide it. And this viscosity, the flow behavior influenced by what? Inside what composite system? You have filler, you have resin, you have catalyst, you have toughener, and you have thermolifier. So you must know what to control your flow properties. So normally flow is from filler. Okay, when you add more filler, viscosity become high or low. High or low. More filler, your viscosity will become high or low.
Hi, hi.
Timing are high. Okay, viscosity will become high. Very difficult to flow. But then sometimes you cannot avoid. You must add in some filler up to certain level. So in order to achieve certain mechanical properties. Okay, so with that viscosity, how are you going to make sure it can be fully filled, from one end to the other end? Ah, okay, so maybe you add the flow modifier, for example. Huh? Second one is thermal. Okay, second one is thermal. So you see over here, thermal, what is CTE? Can you tell me what is CTE? What is CTE? I just want to test you whether you still remember or not. What is CTE? Or you already sleeping in front of your computer? Are you sleeping in front of your computer? Are you? Hey, what is CTE? Huh? Baroha? Ayah, so lama tak panggil Baroha. Baroha? 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 Ada tak dekat sana? Baroha? Kenapa semua ni tak jawab Sama ada you
Ya, doktor.
coefficient of thermal expansion. Coefficient of thermal
Tak
expansion
tahu doktor.
Sudah tahu Fahani sudah jawab dalam chat box. Bagi tengok chat box. Okay. Very good Fahani. Very good. Okay. Wait wait a minute. Anyone got class Nasri ada class kan? Nasri ada class tak? Hari ni?
Tak ada.
Tak ada class So I continue for a while only. For a while So normally ada CTE 1 and CTE 2 So sometimes they write mereka akan tulis macam ni alpha alpha 1 alpha 1 and alpha 2. Kenapa ada 1 and 2? Later on I will explain to you Later on we will learn Okay, we will learn. Ini satu dan two different things. One material must have, especially polymer, must have CTE 1 and CTE 2. Okay, so thermal properties also controlled by TG and also your gel time. So these thermal properties you control by filler, catalyst, and also your resin. So the other one is mechanical. This one is very straightforward. This one for all the while you have learned before. Okay. So mechanical properties regarding to modulus and also toughness. Your resin, toughener, and filler itself. Ionic content is from your resin. Okay, it's from your resin. Ionic content is something that we don't want. Must be avoid. Okay, or else it will cause corrosion. Okay, so environmental normally from your filler or resin. Silica tends to absorb moisture. Silica. Okay, polymer also. Okay, so you will have moisture uptake. That's why the process, remember, you need to pre-bake to remove the moisture before you go for processing, because this one for environment moisture uptake will cause you the voids and a few voids later. That's all for today lah. So before we end, any questions? So I see you after Raya lah. For those celebrating Hari Raya, Selamat Hari Raya. For those bacalah assignment, bacalah lecture note saya. Okay? Happy holidays juga lah. Okay, any question before we end? Any
No
question
question.
before? No Attendance, have you signed in? Last call. Have you signed in? I post one more time. I don't know. I haven't checked last week attendance. Must be very bad. Must be very bad. Okay. So before we end, do you have any questions? If not, we end now. Okay, thank you everyone. Have a very good Hari Raya and also happy holiday. So I see you again after Raya. Okay? Okay, bye.
Okay, doktor.
Bye.
Selamat Hari Raya.
Selamat Hari Raya.